Welcome back to the lecture series of communication system. In this lecture series, I am going to discuss about single sideband suppressed carrier system. Before this single sideband suppressed carrier, I am already explained what is single sideband suppressed carrier, what are its advantage, what are its disadvantage, and its application. So the first method of the generation of a single sideband suppressed carrier is called frequency discrimination method. So here actually in the frequency discrimination method of a single sideband suppressed carrier generation, we can suppress one carrier of a double sideband suppressed carrier system. So the output will become a single sideband suppressed carrier. So for this suppression of one of the sideband from a double sideband suppressed carrier, we required a band pass circuit which have very sharp cutoff characteristics, and a filter having band pass filter having a very sharp cutoff characteristics is difficult to create, is difficult. So it is a most difficult constraint, because if we are using a band pass filter with a very sharp cutoff characteristics, actually we required a higher order filter, so the characteristics is the complicated. And the second, if we compromise on this cutoff, then some of the frequency may lost, because in a actual cutoff frequency in the case of a band pass filter is a brick wall response, but practically we are never get a brick wall response type of band pass filter. So that's introduce a error, and that error will affect frequency component near zero frequency. So in this method we will generate double sideband suppressed carrier wave with the help of product modulator. Again we are using a product modulator, and this particular product modulator nothing but it multiply a message signal to a locally generated carrier frequency. See here, this message is empty and a local generated carrier frequency is called AC cos 2 pi fc. You may also consider sin 2 pi fct. So after the multiplication, we know that output is a double sideband suppressed carrier. So one of the sideband is suppressed just by passing to the band pass filter. So at the output of this particular band pass filter is a single sideband suppressed carrier. Then that is the one method. Then there are frequency phase discrimination method. First is frequency discrimination, second is the phase discrimination method. In this method is based on time domain representation of SSB waveform. It means we are using a time domain principle, and with the help of this time domain principle I am able to suppress one of the sideband. See this particular the block diagram, it consists of a two product modulator. The DSB-SC is nothing but a product modulator, and this particular product modulator is connected with a phase shifter. It means carrier signal apply in one phase modulation is cos omega t, then in the second phase modulator second product modulator is sin omega ct. Similarly, a message signal in the first double sideband signal message is empty, but in the second sideband signal message is m dash t. Again it is a 90-degree phase shifted version. It means if mt equal to am sin omega ct, then m dash m bar t equal to am cos omega m t. So we use this particular phase shifter to generate a phase shifted version of the modulated signal and carrier signal. See this particular explanation, this block diagram of phase discriminator consists of the two product modulator, two 90-degree phase shifter, one local oscillator and one summer block. See it is clear from this figure also. And the product modulator produce an output which is the product of two input. The minus 90-degree phase shifter produce an output which has a phase lag of minus 90 with respect to the input. The local oscillator used to generate carrier signal. Summer block produce an output which is either sum of the two input or the difference of the two input based on the polarity of the input. So this particular, because it perform adder operation, but due to the phase shifting, maybe V1 and V2 is out of the phase or in opposite polarity, so it becomes subtracted, and when V1 and V2 is in the same phase, then it will be added. See this particular whole concept they have expressed by some mathematical equation. Here I am considering mt is am cos 2 pi fc and carrier signal is ct, that is equal to ac cos 2 pi fc. Then we multiply in am ac this cos. Then similarly, if we take after using the trigonometric manipulation, we got fc plus fm and fc minus fm, that become s20. Similarly, in the second signal, it is the 90-degree phase shifted version. See here, nothing. So see this particular equation, it is clear that in that case it's become multiplication of sine into sine. Here there is cosine multiplication, here we got a sine multiplication. Again we use trigonometric manipulation and we are able to create sum and difference frequency. So we have the two signal, both have consist of the sum and difference frequency. It means this particular both the signal actually consist of a double sideband suppressed carrier signal. So after the passing through the band pass filter, one of the sideband will suppress. So instead of the passing the band pass filter, in the phase discrimination method we passes with a adder. See here, when with the single sideband suppressed carrier system, we passes through the adder, so it will add up, both the signal will add up. And when we again use the this, we here we see that this fc minus fm, and here again plus fc minus fm. So if we consider this if we consider this fc plus fm and fc plus fm in the second case, so here it is the positive, here it is a negative, so that will be cancel out and it's become, and here that is equal to am ac upon 2 cos this, again am ac upon 2 cos this, so it's become am ac cos 2 pi this. So it means this particular upper sideband will suppress. If you want to generate a lower sideband, then we use subtractor. So in the case of the subtractor, upper sideband will go out. So it is the basically it consists of the upper sideband. Hence, by choosing the polarity, similarly if here you see that it consists of upper sideband, this particular equation consists of lower sideband. It means just by in the phase discrimination method, by using of adder and subtractor, we are able to create a single sideband suppressed carrier which consists of upper sideband or lower sideband. So that is the one of the advantage of this particular phase discrimination method, and it's the circuit using in the phase discrimination method is more simple in comparison to the phase discrimination method, because the design of a band pass filter having a very sharp cutoff characteristics, or its characteristics is equal to the ideal band pass filter brick wall response characteristics is complicated. So this particular phase discrimination method is more popular in comparison to the frequency discrimination method. But if you are able to use the complicated circuit, then we also prefer the phase discrimination method of single sideband suppressed carrier generator. So that is all about how to generate single sideband suppressed carrier. So it is nothing but single sideband suppressed carrier modulated signal. In the next lecture, I am going to discuss about single sideband suppressed carrier demodulator. So thanks for your kind attention.